Welcome back to Monster Tamer, a 2D Pokemon-like RPG created Phaser 3. Previously, we worked on updating our world scene, and we updated our logic tied to our random encounters and our game. If you missed the previous videos, there'll be links in the video description to the source code up to this point, as well as the complete source code for this video. There'll also be a link to previous videos if you'd like to catch up, so let's get started. So now that we have our basic logic working for picking a random monster that we can encounter in an area, we're going to work on enhancing some of the logic that's tied to this. And so currently, when we encounter an area where we can encounter monsters in our game, there is an equal possibility for which monster we're going to go ahead and encounter. And so what I mean by that is from this array, we randomly pick one of these four numbers here, and then that's the monster we encounter. So we always have a 0.25 chance of encountering one of these monsters because they all have the same possibility of being chosen. And so typically in your RPG, when you encounter monsters, there's a different probability for how frequently certain monsters would appear in your game. And as an example, we can imagine that for our game, let's say Carnodusk is very common to this area. There's a huge population of them. And so maybe there's a 50% chance we'd actually encounter this monster versus one of our other three. Or on the other end of the spectrum, let's say Frost Saber is he's not native to this area in our game. And so it's going to be very rare that he would spawn. And so maybe he only has a 10% chance of actually spawning in our game. And so to do logic like this, there are a few different ways we can do this, and there are a number of algorithms you can use. But one of the easiest ways that we can introduce this functionality is we can go ahead and use what is called a weighted random number. And basically what a weighted random number would be is we would have a list of numbers, and each of these numbers would have a weight associated with it. And that would represent the probability or how important it is for that particular number to be chosen from our array. All right, to go ahead and see a visual representation of how this works is what I'm going to do is I'm going to just draw a couple of quick shapes here. And so we're going to have this rectangle. I'm going to go ahead and just do it pink, and we're going to have one of them. Then we'll go ahead and have our diamond. We'll go ahead and do green. And we'll go ahead and do our circle. And we'll go ahead and do that as blue. And so what we can imagine is if we take our shapes and we place them into this bag or our array, and we want to choose one of them, what we're going to end up doing is we can only pick one of these three. And so for our rectangle, we're going to have one of them. For our circle, we're going to have one. And for our diamond, we're also going to have one of those. And so if we pick one of our objects at random, we have a 33% chance of getting it. And so what I'm going to do is I'm going to add some weights to our object. So how likely we choose that object. So for our rectangle, we're going to have 3. For our diamond, we'll have 5. And so for our circle, we'll have 2. And so with these weights, this is now going to increase the likelihood of that item being available for us to pick. And so what I'm going to go ahead and do is we're just going to draw that many shapes inside our bag here. And so we're going to have our 3 rectangles. We're going to go ahead and have our 5 diamonds. And we're going to go ahead and have our 2 circles. And so now if we picked one of our items at random, we would see that for our diamonds, we have 5 out of 10 or 50% chance of drawing a diamond. We have 2 out of 10 or 1 in 5, 20% of choosing our circle. And then we have 3 out of 10 choosing our rectangle here. And so to design an algorithm to represent this, and so there's a few different ways we can solve for this. And so one way is we take all of our shapes and we can place them into an array. And so what we would have is we would have an array of 10 elements. And now if we pick a random index, we would then grab that shape at that index. And so this works really well for this simple approach. However, as the number of items we add increases, or if we use really large weights, then we're going to take up more memory to represent that array. And we want to avoid doing that because if you imagine, let's say if I had 3,000 rectangles, 5,000 diamonds, then it's going to go ahead and consume a lot of memory because that array is going to be very large. And if we have to choose this random number quite frequently, it's going to eat up a lot of space. So another way we can get the exact same results is instead of placing this number of items in our array, we can actually use our weights to get the same effect. And so how this works is we're going to go ahead and calculate a cumulative weight of our items and use that cumulative weight to pick an item. And so just to see a quick example, what I'm going to go ahead and do is I'm going to go ahead and draw out an array here. And so I'm going to go ahead and just make a pretty big array. And so what I'm going to do is for each of our items based on their weight, I'm going to add for that weight that number of numbers to my array. And so for our rectangle, we're going to go ahead and add in 3. And so we'd have 1, 2, and 3 inside our array. For our diamond, we'll go ahead and we'll have 5. And so we'll just start at the next number. And so what we'll have is we're going to have 4, 5, 6, 7, and 8. So we have 5 numbers that represent our weight here. And then if we go ahead and add our last 2 for our circle, we're going to end up at 9 and 10. And so when we look at this based on just our weights, if we take the same approach, we have the same problem. Our weight array is going to grow based on how big our weight is here. And we don't want to do that. Instead, we want to use what is the sum of our weights to figure out those numbers. And so for our cumulative weights, how that works is we're going to go ahead and we'll have a new array we'll create. And for this array, what we're going to go ahead and do is we're going to add up the weights of our items as we encounter them in our array. And we'll take the cumulative value. And so for our first element, we have a weight of 0, and we're going to add 3 to it. Then when we get to our second item, we need to add our 3 plus our 5, and so we get a total weight of 8. And then when we get to our third and final one, we need to take our 3, 5, and 2 and add them together, and so we end up at 10. And so if we look at our new array, our cumulative weights represent these final numbers for our weights inside our individual numbers here. And what we can do with this new array is now we can generate a random number between 0 and the maximum value of our cumulative weights. And so it'll be our last value here, 10. So based on that random number, we can then choose one of our items here based on which one is greater than or equal to the number we draw. And so if we generate a random number of 5 as an example, we would compare it to here and we'd say, oh, 5 is greater than 3. We're not going to choose from that area. 5 is less than 8, so now we're going to choose an item from this bracket. And that 8 represents our rectangle, our diamonds here. If we drew a number 2, we'd say, hey, that's less than 3. Okay, so what that means is we're going to pick an item from this first bracket or our rectangles. Finally, if we got a number 10, we'd say, oh, 10 equals 10. We need to draw a number from this bracket, so this would represent our circles. And so the reason this works is we can think that our higher weight values are going to occupy more in our numeric space here. And so as an example, we'd say our rectangle only has a weight of 3, so it's only going to occupy 3 out of our possible 10 numbers here. Versus our diamond has a numeric weight of 5, so it's going to occupy 5 of our 10 numbers here. And so by simplifying and just using our cumulative weights, we can see that we can make our array that we're now choosing a random number from much smaller than adding in all these numbers individually. And so just as an example, let's say if this was 300 and then 800 versus 1,000, we can see now if we had 1,000 numbers in this array, this really simplifies and it works with those higher weight values. All right, so now that was a lot of information, but the key takeaway and how to think of this is for our weighted number, what we're going to do is we're going to have an array of indexes for our monsters, or we'd have 3 monsters, and we're also going to provide a weight to that. And for that weight of each of those monsters, we're going to have that many monsters live in that bag or that area of our game, and so with a higher weight, we have a higher chance of actually encountering one of those monsters, versus a lower weight, we have a less likely chance of encountering that monster in the wild. All right, so what we're going to do is let's go ahead and jump back to our code, and we'll go ahead and start working on our implementation. All right, so for our weighted random, what we'll do is we're going to go ahead and make a new function. So what we'll do is let's jump into our source code. Let's go into our source folder. Under our utils folder, we're going to make a new file, and we're just going to call this random.js. And so what we'll do is let's export out a new function, and we're just going to call this weighted random. All right, and so we'll expect one parameter. We're just going to call this data. And so real quick, what I'm going to go ahead and do is I'm going to go ahead and add our types. And so for data, what we want this to be is we're going to want this to be an array of arrays, and we're going to expect it to be all numbers. And so for our array, we're going to have subarrays, and each of these subarrays are going to have 2 elements. One of them is going to go ahead and be our monster ID, and so this will be like our shape from our diagram. And the second one's going to be our weight. And so this will be just the value, so how frequently this monster will show up. And then based on that data, we'll go ahead and pick one of our monsters. And so what we're going to do is we're going to go ahead and split up our data into two separate arrays. And so what we'll do is we'll do const values. And for that, we're going to use our data. We're going to use the map method. And this is going to let us iterate over our array. And so as we're iterating, we just want to return our first element in our array because that's just our monster IDs. And we're going to make this generic, so we're just going to call it values. And then so for weights, we're going to do the same thing, but we want to grab that second element in our array. So the next what we'll need to do is do our cumulative weights. And so we'll make a new variable, and we'll call this cumulative weights. And we're going to set it equal to an empty array. And then what we're going to do is we're going to go ahead and loop through all of our weights in our array here, and then just create our new array. And so what we'll do is we'll do we'll do a for loop, we'll do let I equals 0. Do I is less than our weight's length. And then what we'll do is we're just going to go ahead and increment I. And then what we want to do is we want to go ahead and add our new weight to our array. And so to go ahead and do this, we'll just do cumulative weights. We'll reference our index. And so this will make our cumulative weights match the number of elements in our weights array. And then we want to go ahead and take our current weight and add it to our previous weight if we have one. And so we'll have our weights I plus our cumulative weights. And we'll do I minus 1. And then what we'll do is, because this is going to not exist for our first element, we're just going to add a default, and we'll go ahead and fall back to using 0. All right, then, so what that should do, that should build out our cumulative weights array. And so just so we can test and make sure everything's working properly, what I'm going to do is I'm going to do a console log, and I'm going to go ahead and do our values. I'm going to go ahead and do our weights, and then we'll go ahead and do our cumulative weights. And then what I'm going to do is in our world scene, I'm going to go ahead and call our new function. And then so what we'll do is we're just going to go ahead and call that after we do our random monster ID. And so what we'll do is we'll do our weighted random function. And now for our data, we'll have our array. And for our first array, we're going to match that sample data that we did for our shapes. And so we'll have our first shape, we had a weight of 3. For our second shape, we had a weight of 5. And then finally for our third shape, we had a weight of 2. So then what we should be able to do is we come over to our browser, we should be able to go ahead and test. Let's go up to our encounter area. And so what we should see is we should see the output of our new function. And so we see we have our 3 arrays. And so we have our 3 shapes, we have our 3 weights of our shapes, and then we have our cumulative weights. Perfect. So now that we know we're building our cumulative weights properly and we have the right values, now what we want to do is we want to go ahead and grab the max weight from our cumulative weights and then go ahead and generate a random number between 0 and our cumulative max weight. And so to go ahead and get our max weight, we're just going to do const, we'll do max cumulative weight. And for that, all we need to do is grab the last element from our array. And so what we'll do is we'll take our cumulative weights array, we're going to go ahead and grab our length, and we'll go ahead and subtract 1 to grab that last element. All right, and so now we have our max cumulative weight. We just need to go ahead and generate a random number. And so to go ahead and do that, we'll make a new variable. We'll do const, we'll do random number. And what we'll do is we're going to set this equal to our max cumulative weight. And we're just going to times it by math.random. And what that's going to do is that's going to generate a number between 0 up to our max cumulative weight, but it won't include it. All right, so now we just need to go ahead and return our value based on our random number compared to our cumulative weights. And so what we're going to go ahead and do is we're just going to go ahead and do return, and we're going to do values. And from our values array, we need to go ahead and pass our index. And to get our index, we're going to do cumulative weights. We're going to use our filter method. And then what we're going to go ahead and do is we're going to filter our array, and we're just going to call this element. And what we're going to do is we're going to compare where our element is less than or equal to our random number. And we'll go ahead and grab our length. So what we did here is we took our cumulative weights array and we went ahead and filtered it down to only include elements that are less than or equal to our random number. And we went ahead and used the length of that array to determine how far over we need to go in our cumulative weights array to know what weight to use, and so we know what value to return. All right, and so to see an example of what we're doing is, let's go ahead and we'll do our cumulative weights array real quick. And so we'll have our 3, 8, and 10. And so let's say we generated the random number 0. When we generate the random number 0, then our filtered array is going to have no elements in it because none of them are less than or equal to our random number of 0. And so when we call the length on this, we're going to have a length of 0. And so what will happen is now when we reference our values, we're going to go ahead and grab the value that's tied to this cumulative weight here, which is exactly what we want. Versus, like, let's say if we generated the number 9, then our filtered array is going to go ahead and include 3 and 8. And what that's going to do is that's going to give a length of 2. And so now when we do our length of 2 from our cumulative, we're referring to our weight of 10, which is tied to our third value, which is exactly what we want. And so the reason this works is because when we generated our random number, we made sure that it will never include our final cumulative weight here. And so the length of our array will never include all 3 of our elements. The most it'll have will be length minus 1. All right, so I'm going to go ahead and clean this up, and we should be able to go ahead and test our new function. And so what I'm going to go ahead and do is I'm going to jump over back to our world scene. All right, so what I'm going to go ahead and do is I'm just going to go ahead and make a new variable. I'm just going to call this const t. We'll set equal to weighted random. And then what I'm going to do is I'm going to console log our value. And so now back in our scene, we should be able to go ahead and encounter a monster. And so what we'll see is we generated a random number. And so we returned a value of 1 for our ID. All right, if we go ahead and test again, we'll see if we get a different value. Oh, we got 2 that time. All right, we got 2 again, and we'll test one more time, and we got 2 again. Perfect. So now if we want to go ahead and test some of our probabilities, what I'm going to go ahead and do is I'm going to go ahead and bump 2 up to 10. We're going to go ahead and jump this down to 1, and we'll go ahead and jump that down to 1. And so now what that should do is we should most likely get back the value 2. And so as we can see here in our console log, that is the number we're usually getting back. And so we have a higher probability of getting that number back. Versus, let's go ahead and bump this down to 3, and we'll go ahead and jump this up to 5. What should happen now is we should have more likelihood to encounter number 3, which we happen to there. And if we keep testing, we got 3 again, and we got 3 again, and 3 again. All right, I'm just going to do a few more tests to make sure we get a different number. All right, there we go, got number 2. All right, so now that we've validated that our weighted random function is working properly, what we need to do is we actually need to refactor our encounters JSON file so we can actually include weights with our monsters. And so what we're going to do is we're going to refactor this to be an array of arrays. And so what I'm going to do is I'm going to plug in some weights for our monsters here. And so for our ID of 2, we'll have a weight of 45. For our ID of 3, we'll have 40. And for an ID of 4, we'll go ahead and try 10. And for our ID of 5, let's go ahead and do 25. And so you can go ahead and play with these values if you like, but let's go ahead and sum 2 for now. And so what we need to do now is let's jump over to our type definition file. Let's go ahead and modify our encounter data now that we're getting from our JSON file to return an array of arrays. And then we'll jump over to our data utils, and let's change this to be an array of arrays as well. All right, so now what we need to do is we need to change how we're getting our random monster ID. And so instead of generating this random monster index, all we're going to go ahead and do is we're going to do const. We'll do our random monster ID. We're going to set it equal to our weighted random. And we're going to go ahead and pass in our possible monster IDs. Because these are no longer IDs, what I'm going to go ahead and do is I'm just going to change this to possible monsters. We'll change that to possible monsters. I'm going to go ahead and clean this up. And then let's go ahead and clean up this old code tied to our random monster ID. All right, so now after all of our changes, what we should be able to do is over in our scene, we should now be able to go ahead and test our logic. So we encounter a random monster. So we got Frost Saber there. And so now if we do it again, oh, we got Carno Dusk. And let's go ahead and do one more time. We'll see what we got. All right, we got Ignivolt. Perfect. All right, so then what we're going to go ahead and do real quick is back in our random JS file, I'm just going to go ahead and clean up our console log statement. And then back in our world scene, I'm going to go ahead and modify our logic for our encounters. And we're going to go ahead and bump this back down to 0.2. Alright, with that actually brings this video to an end. In our next video, we're going to work on starting to add support for items on our world map to our game. So as a reminder, there's a link in the description of the video to the complete source code for this video, and as always, thank you so much for watching. I hope you enjoyed the content. If you did enjoy the video, please consider liking the video and hitting the bell icon to be notified when the next video in the series is released. For more great Phaser 3 content, please see some links on your screen now.